Hello everyone, welcome to my channel Chemistry by ANR. Today we are going to deal with separation of components in a mixture. Now it depends on what type of component is present in a mixture, based on which what type of separation methods we are going to select. If in a mixture we have magnetic substance, then of course we are going to use the magnetic separation method. We can use a suitable solvent also as a separation method, where one of the component may be dissolving in the solvent and the other may not. So, choosing a suitable solvent, using a magnetic method of separation, filtration, evaporation, sublimation, distillation, fractional distillation, using a separating funnel and using centrifugation and many more are the methods of separation of components in a mixture. Now it can be a mixture of two solids, or it can be one solid, another liquid, or a mixture of two liquids also. So how are we going to separate those substances, the components in a mixture? Let us explore. Hello everyone. Today's discussion is regarding the methods of separation of components in a mixture. So these are the methods by which you can separate the components in a mixture. That you can see there are 6 methods, even more methods are there, but here focused are 6. One is filtration, second is centrifugation, evaporation third, fourth is crystallization, fifth chromatography, and sixth is distillation. So these are the methods, 6 methods. Now, which method to adopt? How will you know? That depends on the properties of the components that you want to separate. Like if I say filtration, that means obviously one of the component should be immiscible in the other component, where the immiscible component should have a particle size which is greater than the size of the pores of the filter paper. So whichever particle is having size of its own lesser than the pores of the filter paper will pass through, and if it is not, it will be restricted. Now folding of a filter paper in the form of a cone is shown here. Well, I will tell you not to fold it in equal folds. Why, see, if a circular one you are folding it, you get a semicircle, mane half circle like this. Okay, so now this, if you again fold it, you will get this type of quarter type of shape like this. Okay, so this is 1/4 part out of the 4 parts in a circle. So now this part will be containing folds like this. One is a double fold. So here there are double fold and this is a single fold. So try and make it uneven and open out from the larger surface. Why? The reason is the funnel which you are using has a bore which is large at the top and becomes gradually narrow. This is the funnel. So you actually have to place the filter paper on the walls of the funnel, almost covering it neatly, keeping no air gaps. So in that case, I will tell you, fold it in an uneven manner, one larger and the other smaller fold. Okay, so this is how you will fold a filter paper. Separation by filtration, I told you the components should be one immiscible component. Then in that case, I can consider insoluble substances from a liquid. So what are those substances? I can separate sand and water by methods like number one, I can say sedimentation. Why? Because it is gravity separation. Okay, sedimentation means the heavier particles of sand will get deposited, settled at the bottom of the container. So this is sedimentation. Okay, now after sedimentation you can do decantation. So in decantation process, what does it mean? You gently pour out the liquid and you leave the insoluble particles in the beaker. So the beaker now contains only the sand particles and you have poured out, say, the liquid in another beaker. So this is one of the method involving sedimentation and decantation. So you are actually separating the component. Here remains your sand and here remains your water. You can use another method. You can use the filtration method, where if you filter it, then in that case what happens is, what you will get is the water as the filtrate. Water will come out as the filtrate and the sand particles will remain here as residue. Okay, it will remain as residue. Why? Because the size of the sand particles are larger than the pores of the filter paper, so it cannot pass through. But water, the size of the water particles are smaller than the pores of the filter paper, so you can filter it. But keep in mind that this type of pouring, say mixture of insoluble, solid and liquid, when you are pouring it, you are using a glass rod. So when you are using a glass rod, the motive behind it is to neatly pour the liquid. When you use a glass rod, then you neatly pour the liquid through the walls of the glass rod such that it doesn't spill out. Okay, so your work is done in a neat manner without spilling out, or without maybe you are not creating sand and water mixture loss also. Whatever is used for separation purposes. Okay, so we can do this by what I said, two methods, sedimentation and decantation, or directly by the method of filtration, where the residue is water and sand, filtrate is water and residue is sand. Same thing can be done using chalk powder and water. So sand and water and chalk powder and water, it will again work the same manner. Suppose I use one miscible and the other immiscible substance. Okay, so suppose I take chalk powder. I have taken chalk powder, substance A, this is, okay. Along with this, I am using salt, say substance B, and I am using water. Then what will I do? What are the methods of separation? Very neatly we can observe that, okay, chalk powder, component A, is insoluble in water. Component B, salt, is soluble in water. So if we try to separate it out, then what we will do? We have been supplied with these three. If we are not supplied with water, then also we have to choose water as the solvent. The reason is, when you mix it, the salt dissolves and it forms a salt solution, and you get chalk powder remaining as a sediment. Okay, so chalk powder can remain as a sediment. Why? Because it is insoluble and it is heavy. So your beaker may contain salt solution. It may contain salt solution and it may contain powders of chalk, so which is A component, and this is the solution of component B. And so you have separated the chalk powder from the salt, but physically you couldn't separate it. So after this, you can do filtration. If you do filtration, then you will have two parts. One is residue. In the residue, the insoluble chalk powder will remain, and you will have a filtrate where you will have the soluble salt solution. That means you will have salt solution as filtrate. So chalk is already removed. Now you have to remove salt from the salt solution by the method of evaporation to dryness. When I do evaporation to dryness, that means if I use a petri dish, okay, and or maybe a watch glass, and I heat it, and this is your salt solution, after some time you will see only the salt particles are remaining and the water has got evaporated. So these are the methods of separation of what you have taken: chalk powder, salt and water. So if you take water, then salt will dissolve, forming salt solution. Chalk powder is remaining as a sediment. You filter it, then you will get what? You will get as residue the chalk powder, as filtrate the salt solution. And now you evaporate the filtrate to dryness, and what will be remaining is the salt, and what will be going out as vapor is the solvent, which is water. Now you have separated the three components. Or if I give you only chalk and salt, you have separated the two components. Now this diagram is the purification or supply of drinking water in city. Cities are generally, if it is located near the river or lake, that is the source of the water for domestic purposes. So this water is sent through pipe in pumping station, where from it is sent to a sedimentation tank to remove the particles which are bit heavier, which gets sedimented easily. Now after sedimentation, it is being sent to a loading tank, where in loading tank alum is added, which is known as fitkiri. Alum is known as fitkiri, and it is being added. Why? Because there are certain dissolved impurities which gets deposited and gets they remain suspended. Suspended clay particles, very fine particles, which are not otherwise removed by the method of sedimentation. If you give alum to it, they get sedimented easily. Now the water is passed through a filtration tank. Third thing, so you see that in the filtration tank, what happens is the water actually passes from a layer of fine sand to a coarse sand to gravel, where gradually it is getting different surfaces in order to separate out the impurities. And then after passing it through layer wise separation, it goes to a tank which is known as chlorination tank, where the germs are getting removed using chlorine as a disinfectant. So it's known as chlorination tank. Finally, from the chlorination tank, it goes to the pumping station, and from the pumping station, it goes to houses through a water storage tank. Okay, so this is the method, this is the stepwise method how water reaches from river to your home. Number 1, sedimentation tank. Number 2, loading tank. Number 3, filtration tank. Number 4, chlorination tank. Finally to the pumping station. So next, gravity separation was that. Another method is centrifugation. This method is appropriate to separate very fine suspended particles in a liquid. Okay, so examples, very fine suspended particles in a liquid. what is being done is it is taken in a I will say small tube which is known as centrifuge. This is a centrifuge. That is an instrument. Centrifuge is an instrument, and you can see the centrifuge tube holders. 4 tube holders are kept over there, and a liquid which is taken over here. Now sample is taken over here, which is blood. Now blood is a mixture of blood cell and plasma. Now you otherwise cannot separate the plasma and blood cell by filtration or by evaporation to dryness is not a suitable method. The suitable method is centrifugation, where the centrifuge tube is taken, and when at high speed, having a rotational motion, as well as it is revolved with high speed. This motor over here is revolved with high speed, followed by rotational motion, and by the gravity separation you will see that the blood is separated from the plasma. This method is faster than any filtration method. Filtration using a suction pump may be faster, but centrifugation is another method where you can actually use a centrifuge tube and you can enhance, you can increase the rate of separation, the speed of separation. And certain applications are clay particles. Clay particles suspended in water can be separated. I told you blood and plasma. Centrifugation is the method. Okay, so here we can see that when the switch is on, what happens is the centrifuge rotates, it spins at a very high speed, and due to the centrifugal force acting on the suspended particles, they settle at the bottom of the centrifuge. So the spin motion, the rotational motion separates the substances, impurities. So separation of cream from milk, this is also done by centrifugation method. So it is done by centrifugation method. It is used in washing machines also to squeeze out water from wet clothes and make them dry. Now the method of filtration and centrifugation which we have discussed can be used to separate insoluble solid from liquid. Now there are other methods also, which is evaporation, crystallization, chromatography and distillation. Here we are seeing evaporation, which we have discussed. I said common salt and water. Evaporation to dryness can be used, and this can be used as a method of desalination. You see common salt and water kept in a petri dish or maybe a china dish and heated. The water, the solvent evaporates, left behind is the common salt. The process of evaporation can be used for desalination purpose, large scale, in order to obtain or rather separate the salt from the water. Okay, and this sea water is kept in shallow lakes which are known as lagoons. Okay, and they are allowed to stand in these lagoons, and under the heat the water gradually evaporates. It may be a slow process, but large scale of accumulation of the salt can take place. Okay, so next we can also use it for the substances like potassium, potassium nitrate, etc., to separate it from the water solution because they are water soluble. So what type of impurities can be removed by evaporation? The dissolved solid impurities or substances can be removed by evaporation to dryness, where water is evaporated may not be recovered, but the dissolved solid is separated. Mark my words, what I said. The dissolved solid is separated, water is evaporated but is not recovered. Now, The other thing is we can use blue ink or black ink in fountain pens. It is a liquid mixture. Now we can again use the evaporation method where the dye remains and the solvent evaporates. Okay. Next, there are other methods for discussion. This is the separation of the dye, the diagram, separation of dye from ink. Okay, so this is the method. The other method is crystallization, method of obtaining a crystal by cooling hot concentrated substance in order to obtain crystals. So how this process is done? Suppose I want to obtain crystals of copper sulfate. You know, copper sulfate is CuSO4.5H2O because it remains in hydrated form, and this copper sulfate is known as blue vitriol. It is known as blue vitriol, and it is water soluble. It is water soluble. Now you may think, okay, then in that case we will carry out evaporation to dryness, right? You can do evaporation to dryness where copper sulfate will be remaining as residue and the solvent water will get evaporated, and thus you can separate it by the method of evaporation to dryness. But what if I want the crystals of copper sulfate and in a neat crystalline form? What I need to do is I have to prepare a hot concentrated solution of copper sulfate by dissolving the copper sulfate, and then I am heating it. Okay, so when I heat it, I can use a water bath for indirect heating. When I heat it indirectly, I get a concentrated solution. What is the difference between a concentrated and a dilute solution? Dilute solution contains more of the liquid or the solvent, or here it is water. So dilute solution means more water content, and concentrated solution means relatively less water content and more of the solute content. So if I heat it, I will get a concentrated solution due to the evaporation. Okay, so a saturated solution is obtained. What you will do is, after you obtain a saturated solution, it is hot, you have to gradually cool the solution, keep it undisturbed. With time, you will see the impurities remain dissolved in the solution, but the pure crystals of copper sulfate, they separate out beautifully, and you can see this crystal clear copper sulfate. And then you can use the method of filtration in order to remove the dissolved impurities as filtrate, and now you can evaporate to dryness the filtrate. So what all methods I said? First, I have to heat it with water. It's water soluble. Blue vitriol solution I will take, and we will heat it in order to get a hot saturated solution of copper sulfate. This hot saturated solution of copper sulfate will now be left for cooling undisturbed. You will not be allowed to disturb it. Why? Because then the texture of the crystals will be not that good. So keep it undisturbed. Then you will see two things. One is the crystals of copper sulfate getting separated out in a clear solution. This clear solution may contain dissolved impurities. It may contain dissolved impurities. What you need to do is you need to evaporate to dryness this clear solution such that the impurities remain behind and the water gets evaporated. So you are getting the crystals of copper sulfate, you are getting to collect the dissolved impurities, and the water is getting evaporated. Now in all these methods you are seeing the water is actually getting evaporated. And this method of obtaining the pure crystals is known as crystallization. Separation by chromatography. Now the term chrome comes from chroma, which means color. Okay, so chrome actually means color, and graphy means something which is happening in paper. So it is a method of separation of two or more dissolved component which has different rates of dissolution, or it has different levels or solubilities in a particular solvent. There may be two components or three components which are all maybe soluble in a particular solvent or may be soluble in water, and it may have different levels of solubility. It may have different levels of solubility, and I can assume that okay, let it be in this manner that A is having less solubility than B, is having less solubility than C. So it will be separated on the basis of difference in solubility in a particular solvent. That is chromatography. All the components are soluble in water, but their solubility is not the same. Then they will be separated in this order of solubility only. For that, this is your chromatography paper which is being used, and here a pencil line is drawn, leaving some gap from the bottom, say 3 centimeter gap. This is your rectangular shaped chromatography paper. At times it is mentioned that it is the filter paper, but keep in mind it is not the ordinary filter paper. It is known as a chromatography paper. It is a bit thicker than an ordinary filter paper. So after you collect this, draw a line, say 3 centimeter apart from the bottom, and then the mixture, a drop of this, if you want to separate the mixture of the components of ink, then the drop needs to be given at the middle of this line, and the entire setup needs to be dipped in a solvent in such a manner that the dot which you have given, this is not immersed in the solvent. It is above the solvent and it is covered. It is covered. Now this paper obviously has a clip over here. It will not fall into the solvent. This is the solvent which is used to run through the paper due to capillary action, and this is your mixture. Okay, so when the solvent is made to run by capillary action, it moves up through the chromatography paper and it actually washes off the ink, and the component which is having comparatively less solubility will say separate out at this level, component A, then say component B separates out at this level, and component C separates out at this level. How will you know? By the time it reaches that level, you can see a spot for that component pertaining to its own color rising to a particular level, because beyond that it doesn't have its solubility, okay, in that particular solvent. So this layers of separation which you are getting in this chromatography paper, this paper with the layers of separation is actually known as a chromatogram. Chromatogram means as if it is a paper which has different layers of the components based on the difference in the solubility of those components in a particular solvent which you are using and which you are running. Now, next, after this, you can go to the process of distillation. This is a very important process where random heating and cooling is done in order to remove substances, say where the soluble impurities can be removed. Okay, so water, here you have seen that salt and water, in salt and water you are unable to recover the water. If you use evaporation to dryness, the water goes and the salt remains. What if I tell you that you have to recover the water also, collect the water also? Then in that case, distillation is the process of heating and then of course cooling it and collecting the liquid which is obtained as a vapor, and you collect it in the liquid form which is known as distillate. So let us see a setup where we can understand what actually is happening. So here it is a distillation flask. Salt and water mixture is taken in the distillation flask. We can see salt and water mixture is taken in the distillation flask and it is heated using a burner, and it is placed in a tripod stand using a wire gauge. And when you heat it, the vapors or the steams that are obtained that rise up and gradually cool down. When they rise up, there is something to monitor the temperature, that is the thermometer, and it is corked in such a manner that the vapors doesn't escape but pass through a Liebig condenser. This is known as a condenser which is known as Liebig condenser, where it is a water condenser and the vapors are allowed to pass through and get cooled and get collected in the beaker in the form of pure water. Okay, so here in distillation process, you always remember that a distillation process can be used when you want to separate dissolved impurities from liquid. Dissolved impurities in liquid. Then in that case, what you do is first you heat it, then you obtain vapors, and these vapors are cooled, and by the method of condensation you obtain the liquid which is actually known as distillate, and what remains in the distillation flask is the residue. Maybe the salt is remaining as the residue, and in the distillate you are getting pure water. So this is being done in some of the countries. Seawater is actually undergone. The seawater undergoes this type of process of distillation, and the salt gets removed, and it is done in a desalination plant. Next, separation of a mixture of two or more liquids. Till now we have seen solid in liquid or maybe solid in solid mixtures. Now solid in liquid can be two types: miscible, immiscible. If it is immiscible, you use the method of filtration. If it is miscible, then you use the method of evaporation to dryness. And if you have to collect the solvent also, you can use the method of distillation. Separation of two liquids can also be done. Two or more liquids can be separated by the method of distillation. It can be separated by the method of distillation. It can be separated by the method of fractional distillation, and it can be separated using a separating funnel as well. So let us see one by one. One by one means distillation we have already seen. Okay, what will happen? The one which is having a lower boiling point will be actually obtained as the distillate first, and the other one will be remaining as residue. Now in case we have to do the fractional distillation, for this it is used for separating two or more miscible liquids by the method of distillation in steps. okay, where the separation of the two liquids are done on the basis of difference in their boiling points. The one which is a lower boiling liquid gets distilled first, and the column which is used here is known as fractionating column, and this fractionating column generally contains glass beads. It's a cylindrical column containing glass beads where the surface area increases. The purpose of giving glass bead is to increase the surface area, is to cool the vapors of the liquid in steps, in fractions, and finally cause a better cooling effect. So mixture of alcohol and water can be done separated in this manner. We know alcohol is more volatile, but it is miscible in water. The boiling point of alcohol is lower. It is 78 degrees Celsius, and the boiling point of water is 100 degrees Celsius. So obviously, if I take a mixture of alcohol, say I take ethanol and I take water, which one will be separated first? Obviously, here ethanol will be separated first because it has a lower boiling point than water. It's around 78 degrees Celsius and water is 100 degrees Celsius. So let us see the pictorial representation in order to understand better. Now, if the alcohol and water mixture is heated using a burner, then what will happen? It is heated in a distillation flask, and then this is your fractionating column, the glass beads which I said. There, it is done in such a manner that gradual heating is done, and the temperature at the bottom we can see is more, and as it rises in the fractionating column, the temperature decreases. So as you rise high in the fractionating column, so the upper part of the fractionating column is obviously cooler, and the hot vapors, they rise up in the column and get cooled. They condense and can be collected after condensation. You are seeing that in a water condenser, you can collect the one which is having a lower boiling point, say alcohol, and what will remain is water. Okay, so this is possible if it has a difference in the boiling point. Now, when the temperature at the top of the fractionating column, actually the temperature is less than the bottom. But with time, the temperature gradually increases on the top also. So when it reaches the boiling point of the lower boiling component, it passes as vapor through the through the condenser, water condenser, and finally gets condensed and get collected separately. And the water, when you heat it even more, when it starts boiling, then it will again get collected as by condensation method. This can be done in two separate containers and can be collected in fractions, in steps. So this type of distillation is known as fractional distillation. This is a laboratory setup where fractional distillation is being done. Next, we can see the application of fractional. One important thing is over here that we can see that fractional distillation separates various liquids as per their boiling points. The more volatile liquid having a lower boiling point will distill first, and the one which is having higher boiling point will distill later on. So acetone has a lower boiling point. So we can see acetone has a boiling point of 56 degrees Celsius and alcohol has a boiling point, say I have taken ethanol and this is having a boiling point of 78 degrees Celsius, and water which has a boiling point of 100 degrees Celsius, all are dissolving in each other. Means acetone dissolves in water, alcohol also dissolves in water. So if I carry out fractional distillation, acetone will be separated out first, then alcohol, and then water, based on increasing order of their boiling point. The lower boiling liquid will be condensing first, followed by the higher boiling liquid. So this is how you can practically use it. Separation of gases of air, that also you can do by liquefaction and fractional distillation. Why? Because the liquid air has different boiling points. Okay, so let us see how this is done. The air is compressed, cooled, because of which it actually liquefies. Separation of the major gases we are seeing. This liquid air is subjected to fractional distillation, and the different components in air, the different gases in air which are liquefied, they boil at different temperatures. The one that boil first will be separated first. The one that boils second will be separated next, followed by the third. So this is how it is being done. Now, separation by separating funnel. This is done when you take two immiscible liquid or maybe three immiscible liquid. It is separated based on the difference in their densities. And it is another example of gravity separation. Based on the densities, the denser liquid will be at the bottom of the separating funnel and will be separated out first, and the less dense liquid floats over the high dense liquid and is separated later on, where you can actually see the different layers of the liquid because they are not mixing properly, they are immiscible. So here you can see like kerosene and water mixture. Kerosene is lighter, it floats, and this is your separating funnel. The heavier water is at the bottom, and there is a stopcock which is actually used as a knob to release, to open and close. So when the two distinct layers are seen, that means the lighter liquid is floating over the heavier liquid. You open the stopcock or you release the stopcock. Releasing the stopcock means opening the stopcock. Then the heavier liquid will be separated first and then you close it. Let the thistle funnel or the separating funnel have the lighter liquid and collect it in a different beaker. So you can use it for two different liquids which are not getting mixed up. Petrol and water can be separated using the separating funnel. Let me tell you one thing, that it is always not necessary that water will be the high dense liquid and the other component will always be floating above water. If you use any component which is heavier than water, then of course that will be separated first. That is, the denser liquid will be separated first, will be at the bottom. The lighter one will be at top. Now, groundnut, cooking oil, mustard oil, they are immiscible with water, and this can be separated using a separating funnel. Similarly, mustard oil and water can be separated using a separating funnel. But you always need to keep in mind that groundnut oil and mustard oil, they are lighter than water, and hence the upper layer in the separating funnel will be formed by groundnut oil and mustard oil. But there are certain liquids which are heavier than water. Okay, so mercury, carbon disulfide, see, mercury, carbon disulfide, chloroform, benzene, ether. These all are immiscible with water and a mixture can be taken. But remember that mercury, carbon disulfide, these all things, chloroform, are heavier than water, but benzene and ether are lighter than water. So what we said, benzene, ether, and then oils. Which oils? Mustard oil, coconut oil. These all are lighter than water. They are lighter than water. Hence, what will happen is these will actually float over water. But if we use liquids like mercury, okay, I use mercury. You know it is a liquid metal, so I can use mercury. I can use carbon disulfide, CS2. I can use chloroform, CHCl3 is chloroform. So we can use this, where these are what? These are heavier than water. These are heavier than water. So what will happen? These will remain at the bottom and so will be removed first, and then water will be removed. So separation of mixtures. How can you separate iron filings, ammonium chloride and sand from a mixture? What all things are used? Iron filings are used. Okay. Then what is used? Ammonium chloride. NH4Cl is ammonium chloride, and sand. Please analyze them properly and think about the properties of the substances that are actually used here. Like if I say iron filings, this can be removed, number one, by magnetic separation. So you use magnetic separation method and then you can remove the iron filings. What will be left over is ammonium chloride and sand. Okay, now don't think that okay, ammonium chloride dissolves in water. Yes, I know it dissolves in water, but ammonium chloride is also a sublimable substance. So instead I will say you undergo sublimation, where under the process you will have sand as the residue, and when you do sublimation you will get vapors of ammonium chloride which can be condensed to actually obtain a sublimate. This sublimate is nothing but ammonium chloride again. So you can obtain this method of separation. I mean, obtain these three things by this method of separation. First, you can do magnetic separation to remove iron filings. Then you can do sublimation. After you do sublimation, what will be happening is sand can remain as the residue, and as the sublimate you will get ammonium chloride. If you can see how this can be done, you can consider this, that suppose you are having a beaker above which you have taken a funnel. Okay, and here this is the stem of the funnel and it is having a cotton plug such that vapors are not getting removed. Now here I have taken NH4Cl and sand, and I am heating this using a burner, so I will get vapors of NH4Cl which can actually cause condensation, and this is your sublimate which gets cooled. The vapors gets cooled gradually when it rises up and forms solid NH4Cl, can be removed as a sublimate, and what will be remaining over here is sand. So I hope the explanation is clear to all. Now, describe a method of separation common salt from a mixture of common salt and chalk powder. So let us see another example. Say I have taken common salt, means I have taken NaCl and chalk powder. Now this NaCl is soluble in water, this is soluble in water, and chalk powder is insoluble in water. So first and foremost, to this mixture, what we can do is add water and you stir it. Then you will get a salt solution. Okay. And along with this, the chalk powder will remain at the bottom of the container. After this, you undergo filtration. When you undergo filtration, in the residue, you will see that you are getting the chalk powder because it is insoluble and its size is greater than the pores of the filter paper. And as the filtrate, you will get the salt solution. Now this salt solution can be again undergone evaporation to dryness, can undergo evaporation to dryness in order to actually have the residue of salt and the water getting vaporized, forming vapors, water vapor. So this is what you have done. NaCl and chalk powder is given to you. You take water, dissolve. You will see NaCl dissolves, chalk doesn't. So now you filter it. As the filtrate, you will see you are getting the salt solution, and as the residue, you are getting the chalk powder. Because the chalk powder is insoluble in water and has a particle size which is greater than the pore size of the filter paper. Now the salt solution you can evaporate to dryness in order to recover the salt as residue. Now another question, you are given a mixture of sand, water and mustard oil. This is another one. Okay. So you are given sand, you are given water and you are given mustard oil. Now you know it's easier to first remove sand. Okay. So pehle hi you just filter it. You just filter it. When you filter it, your residue will be the coarse sand particles, and this is what is your residue, and your filtrate will contain what? It will contain water and mustard oil. Now this mustard oil is not heavier than water, but it is lighter than water, and so it can be separated. Water and mustard oil is two immiscible liquid, and now you can use a separating funnel where you will see that the bottom layer which can be removed first is having a denser liquid, and that denser liquid is formed by water, and the top layer that contains the lighter liquid, and this lighter liquid will be your mustard oil. This is how you can separate mustard oil, water and sand or chalk powder, anything, whatever you will say. So here first filter, remove the sand. From the filtrate, you can remove water and mustard oil by using a separating funnel where mustard oil floats over water. When there is a clear level or of separation, layer of separation, you open the stopcock of the separating funnel and you remove the more denser water and then the less denser layer of mustard oil.